Hi, welcome to another video. The other day I showed you how to use my font on an ILI9341. I explained you could change your font to whatever style you like. I thought I'd show that today and some of the caveats, some of the pitfalls of using Microelectronica's Font Creator. Microelectronica's Font Creator is a free tool, however I did contribute many years ago. I made a donation. I'll walk you through the process of changing the font from this segment 16 by 22 to a font called Curls, which I like the look of. So this is the current C file you saw just a few minutes ago. X is a random number, write the number X, delay it for 100 milliseconds so you can actually see the number changing, otherwise it's too fast. So if I scroll up to the top of this C file, that's the current font. I explained in the ILI9341 font video, you drop the number font in here, so ASCII 48 to 57. And that current font was developed for a small colour screen 128 by 128. It looks a bit small on this larger screen 320 by 240, so let's create another font. That's the number font. We scroll to the right. You can see there's some additional characters. So ASCII 48 is 0, ASCII 57 is 9, then I've got A, B, C, D, E, F for the hexadecimal video I did the other day. So the current font is segment 14 and it measures 16 by 22 pixels. 16 by 22, it's 44 bytes long per character. 16 by 22, so 16 pixels wide by 22 tall. 16 times 22 equals 352 pixels. Divide by 8, 44 bytes per character. As I said, if you want to show each character and not have to blank it before showing another, you fill each character's footprint with another character. So I saw some fonts the other day. I liked the look of Curls. I'll show you. Let's create it. There's Microelectronica's Font Creator, available at microe.com for free. So at new font, import existing font. There's the normal default Tahoma, but I want Curls. So type in the beginning, C-U-R, Curls MT. You'll see why it's called Curls with a Z. We'll go for bold. Let's make it big, 36 pixels tall. Now I want just the ASCII characters 48 to 57, which is 0 through to 9. 48, 57. This removes all the common empty columns and rows if you tick all these boxes. So click OK. Depending on the speed of your computer, this can take a while. Or it's a massive font, or you want the whole alphabet. Right, so that's finished. 26 pixels wide by 36 pixels tall. So if we flick down, so that's a 0. Oh, whoops. If you left click with a mouse button, it draws a pixel. If you right click, it undraws. So I don't want to save the changes to that. Have a look at the number 1. That's shifted over to the left. I don't know why the one's always shifted to the left. You want the one in the middle. So you can just use these buttons up here, put it in the middle. So we do want to save the changes. Just have a flick through 2, 3. Notice these fonts are starting on the bottom row. 4, 5, 6, 7, 8, 9. If you're like me and you're used to designing fonts, you can see there's a problem already. 9, 8, 7, 6, 5. Look at this 5, 4, 3, 2. But 2's not starting at the bottom. 1, 0. 0 is not starting at the bottom. With the exception of the 5, they all have common empty rows up here. So why does that matter, you might ask? Well, let me show you. 1, 2, 3, 4, 5, 6, 7, 8. That's 1 byte. I'll miss 1 so you can see the bytes. 1, 2, 3, 4, 5, 6, 7, 8. That's the second byte. Then 1, 2, 3, 4, 5, 6, 7, 8. That's the third byte. And then 1, 2. We're into the 4th byte to write nothing. Bytes take time to write. So if we are filling each character footprint with either empty spaces, the background color, or the character, the pixel, these all take time to write. So 1 byte, 2 bytes, 3 bytes, 4 bytes, because you can't have part of a byte, not unless you're bit banging. 1, 2, 3, 4, 5, 6, 7, 8 on the second row, 9, 10, 11, 12 on the third row. 12 bytes of nothing for the majority of the characters. That all takes time. A byte might only take nanoseconds to write, but add them up for all the characters, you start running into microseconds. So you've got to do something about it. You can optimize your font. So let's shift this 0 down. Get rid of these bytes up here. Right, so save the changes. So we want them all starting on the bottom row first of all. Already shifted the 1 over, 2, 3, 4, 5, 6, 7, 8, 9. Right, so they're all starting on the bottom row. So 0 has 4 empty rows. 1 has 3 empty rows. 2 has 4 empty rows. 3 has 3 empty rows. So 4, 3 empty rows. 5 has no empty rows because of this squiggle. And because of this squiggle, all the other characters have got these empty rows. Now, Microelectronica's method of writing this font, this would obviously write all those pixels, and for the other characters it would ignore these zeros, it wouldn't include them. So for that it doesn't matter. If you then come along and write 5 over the top of this 4, A, it's not going to clear any of this, and B, 5, you're just filling in these additional bits up here. But then when an 8 comes along, you'll have an 8 and those curly bits still up there for the number 5. Not to mention the 5 over the top of this. Yeah, something like that. But we don't want that, so don't save the changes. I think on average we've got 3 empty rows per character. So we want to do something with this character 5. If you're not concerned about time, it doesn't matter. But I am for a fast font. So if we get rid of these, we could do something like that. Obviously you can spend some time. That doesn't look sharp enough there. I think I'll leave it like that. So that's the number 5. Save the changes. 4, 3, 2, 1, 0. Right, so now we've got 3 empty rows on all the characters, and they're all starting at the bottom. Right, so let's get rid of the first problem, all these empty rows, because they all take time to write. So we want to delete the top rows. delete the first row, delete the first row, delete the first row. Right, so I think, right, so one needs that top row, and 3 needs the top row. So we'll leave it at that. We've got rid of 3 rows from every character. That saves nano or microseconds per character. If you're writing out, let's say, in integer, so up to 65,535 for an ADC, all those empty rows take time to write, so get rid of them. As I showed earlier, we've got 4 bytes. Yet these characters, if I shift this 0 over to the left, we've got 2 empty columns here. So save the changes. 2 empty columns there. Doesn't matter about that. We've got a stack of empty columns. Loads of empty columns there. Loads of empty columns there. 4, let's shift it over to the left. 2 empty columns. 5, so save the changes. 5, we can shift that over 1 and have 2 empty columns. Save the changes. 6, shift it over 1. Save the changes. 7, a stack of empty columns. 8, stack of empty columns. Shift it over 1, so we've got 1 space on the left. 9, right, 1 space on the left. 8, 1 space on the left. And notice no empty rows above the 8. 7. Let's move that over 1. I'll show you why. Save the changes. We'll come back and put these in the middle maybe later. I'm concerned with getting rid of the extra byte. Just here. So that's the start of another byte here. So we've got a byte there times, this font is now 33 pixels tall, so that's 33 bytes being written unnecessarily, so we can get rid of them. Before we start removing these extra columns, we want to make sure none of the numbers are encroaching into that space. 4. So you can see that number 4, it's odd, it looks like a 2 and a 1. That number 4 is going to have no spaces on either side of it. So 5, 6, 7, 8, 9. Right, back up to the 0. Get rid of those, otherwise they'll be shifted over. So save the changes. Now we can delete the last 2 columns. Go to this red one here, delete last column, delete last column. Right, so the 0 now has no empty columns. 1, sort of put it in the middle, I'll shift it over 1. Save the changes. 2. This is now the finished width and the finished height, so we can center these characters up. So 2 columns either side of the 2. Save. 3. Center it up. Right, so that's 3 columns there, 3 empty columns there. Save the changes. 4. No empty columns either side. 5. 1 each side. 6. 1 each side. 7. 3 there, 3 there. 8. Put that in the middle. We'll have 2 on the left and 3 on the right. So you'll see something in a minute. These empty columns precede the character. These 3 empty columns come after the character. That's important. I'll show you why. Save the changes. 9, that's in the middle. So we can do no more with the width and the height. and we've got a font size of 24 times 33. So if we start on a 0, now if you look at the bytes, 1, 2, 3, 4, 5, 6, 7, 8, miss one, so 1, 2, 3, 4, 5, 6, 7, 8, miss one, 1, 2, 3, 4, 5, 6, 7, 8. We've now got a number font of exactly 3 bytes wide, and most TFT interfaces expect a byte to be written to the interface. So we've optimized our font as much as we can for writing a character and filling a footprint. Up here, export for TFT and new GLCD new library. We want it micro C, that's the name of the font. ASCII character 48 to 57, so 0 to 9. Copy to clipboard, close. This was my previous font, so let's just come down here, make a space. Because we are writing the numbers directly and not using microelectronic as a library, we can get rid of this header. Some of these numbers here include the size of the font. Get rid of all this. That's our new font. Because I've changed the column width and column height, it's giving us all the bytes here. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We've got the same number of bytes. So how many bytes should we have? Let's see. 24 times 33. So 24 times 33 equals 792 pixels, 3 bytes wide, 33 down. So divide by 8 equals 99 bytes. Let's check. 4, 5, 6, 7, 8, 9, 10. Well, I've just got to the end. There are indeed 99 bytes. It just shows you going from this smaller 16 by 22 with 44 bytes to this font 24 by 33, 44 bytes. We've more than doubled the amount of bytes we've got to write. We've now got 99 bytes. Now I've got the character array, the font array here. Let me delete this and start again, and I'll show you what usually happens. Import existing font, don't save the changes. Same font. Curls, MT, bold, 36 tall, 48, 57, OK. Right, so I haven't touched this font at all. There's number 1. 9, 0, 1, all these empty rows at the top. Copy to clipboard, micro C, copy to clipboard, close. I can close this now. Don't think I need it. Don't save the changes. Paste. Right, this is now the standard font that Microelectronica's library would normally use. If I scroll across, hello, look at the number 49. That ends there. 49 ends down here. So that's 0, 1, so 2, 3, 2, 3, 4, 2, 3, 5, 6, 7, 8, 9 of this length. 0 is right up there, along with character 52. We can come to tools, ASCII, character 52. Number 4. What happens in the conventional font when being written by Microelectronica's TFT library and not a custom routine like mine? All the empty columns it ignores. It does not copy them. So you could say, great, that saves you a ton of bytes, which it does. Saving all those nanoseconds there. Great. Except by the time you've written them, then had to blank them because they were being written over, had to blank them, rewrite them in the background colour. It's taking longer than mine. So my font ends there. If you look at the beginning, they all start at the same indent. Scroll along. That's 99 bytes here. Can I use the down arrow? Yes, I can. And my screen capture is showing what I'm doing on the bottom. Down, 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 down. So that's 99 bytes there. Just here. Hopefully you can see my mouse moving. That's 99. Do you remember all the extra bytes that were being written? Because it was 2 additional columns. So in one sense, my numbers, those numbers, are going to be written faster than these because these have got additional bytes. And certainly these 2 numbers here, character 0, and I forgot what it was, character 52, number 4. So the character 0 and the character 4 are taking much longer to write than my character all the way back down here. So it's horses for courses, swings and roundabouts. But then you could argue, well, look at the number 1. That's got half the amount of bytes because of all the additional empty columns after the figure 1. But as I've explained, if you have to write the font, then write it again in the background colour and have a delay so you can see the number. No, my method will win. No flickering, no flashing. As fast as you could expect or want for any ADC or any measurement you're taking from any device. So we'll delete the standard curls font. Here's the one we copied earlier, deleted the header for my routine. All we need to do is really rename this curls because my routine only looks for a font called number font. So we've still got the name here. So what's the name? Unsigned short, number font. So come down to curls. So it's 24 by 33, which we've got there. We know it's 99 bytes long. We've got to name that number font. Number underscore font. And you can't have 2 things in the same C file with the same name. So if I just create some space here, in Micro C you can select everything, right click, comment it out. So my new number font is now that curls, which is twice the size, so expect it to take twice as long to write. If I delete these spaces underneath, so all we need to know down here, the font start for character 0 is 0. The font length bytes we know is 99, put that there. It is 24 by 33, so 24, I've got a note there. The TFT display memory wants to know how many bytes you're writing in bytes, remember? You can't cut it short. And we've got a neat 3 bytes, which is 24 pixels. So 24 pixels wide by 33 down. So it doesn't matter about the height. 33 down. Remember the number 4 didn't have a space. I think the 0 didn't have a space. So let's just put 1 space there. Now in theory I should be able to compile this, except I've got my microphone plugged into where the dongle goes. Should be able to compile this and run it. End off. Let's try it. There we go. That's our curls counting in a while 1 loop. There's no delay. We don't have to look at the tenths or the low numbers. Just look at the higher numbers. So I've shown you exactly how to change the font for my custom write number routine. I said earlier write number font, but I meant write number routine. Designed and built by me. It's still work in progress, still things I can improve on, but you've now got the basics. You write one character once. Forget about it. You can see it's up to an integer now. It's quite happily counting, no need to blank. So it is superior to many other methods. I'll put the C file in the show more later. If you want to use the font, you're welcome to use it, share it. You can't sell it. If you want to make a donation for the work I've put into creating that function, please click on the link and show more. Hopefully you've learned something about fonts and you've learned a bit more about my writing numbers routine. Thank you for watching.